Hello all, I'm here trying to demonstrate the app control on Linux server. So let's get started. The Linux Application Control System for RHEL 8 provides a complete lockdown mechanism with a maintenance mode for automatic whitelisting of executables. Let's get started. I'm using an RHEL 10 machine and I'll walk you through the installation and configuration of app control. During installation, app control requires a dependency package. We'll install first, and I almost forgot to mention this is still a development stage application control. Once all testing is complete, I'll be making it available for everyone. It's really easy to install, and even someone new to Linux can set it up without any trouble. Let's try to install it. Now the app control package installs successfully. After installation, we have access to all app control commands and setup options. The first step is to set up the RPM execution control system. To do that, we simply run the install hook command. As you can see, the RPM wrapper and configuration have now been set up. We can verify the status using the app control status command. Currently, the system is in lockdown mode. System hooks RPM execution controls are enabled by default, and core system paths are automatically excluded from blocking. Since they are critical for the OS, it never set to block. Since this is a fresh installation, no executables or RPMs are whitelisted yet. Similarly, maintenance mode also doesn't have any items. Now, let's try installing an RPM package. I have a telnet RPM available in this folder. When I attempt to install it, you'll see that app control blocks it because the RPM is not whitelisted. Since it isn't whitelisted, app control intercepts the RPM command and blocks the installation. And it also gives you options on how you want to proceed. Whether you want to allow it temporarily or white it permanently, you get the choice. Let me explain. Now, app control provides three options in this scenario. Whitelist the RPM, temporary allow mode, and a maintenance mode. Temporary allow mode is useful for quick on-time operations. But once the time expires, the same action will be blocked again unless explicitly whitelisted. Let's allow the telnet RPM and install it again. Whitelisting is quick and easy. You can do it on the go without any complicated commands. Now the package installs successfully. Now let's check if the violet entry appears on the status page by using the status command. Yes, it is there. RPM whitelisted is appearing in the status page. We can view all commands using the argument health, which will provide all the available commands. The show vehicle command will list the packages names here. You can see the telnet listed under RPM whitelists. Even if an RPM is whitelisted during installation, the removal, erase operation is still controlled separately. The removal is validated to the full command string, so uninstalling a package also requires the corresponding entry. Since telnet is placed in a permitted path after installation, the binary itself can run. It won't restrict running the program after the installation is complete. but installation and removal activities remain controlled by app control. Now, let's check out the maintenance mode. When we start maintenance mode, it runs in the background. Anything executed during this window automatically gets captured and allowed. We can view the maintenance mode logs to see what's being captured. Let me grab the commands. As you can see, several system executables and files are being whitelisted in the background. In a production environment, I recommend running maintenance mode for at least one full day to ensure all dependencies and required executables are captured, reducing the risk of production impact. Once the maintenance work is completed, we can stop the mode. It shows how many items were captured. Here it captured 29 items and these are now fully whitelisted. Now we can stop the maintenance mode. Here it captured 29 items. In this mode, you don't need to manually allow anything. Everything gets handled automatically. Let me show you the status section again. In the status section also, the maintenance captured count is listed. The count we saw earlier will appear here as a summary. Next, let's address a common question. What if a user has sudo privileges? Can they bypass the restrictions? Let me quickly add a test user and let's try that. This is a common production scenario where a server may have multiple sudo users, and those permissions could be misused to run unwanted commands. In a production environment, we might not even notice it happening. So let's take a look at how this works. Before testing that, let's uninstall the telnet RPM we installed earlier. I'll use temporary allow mode for this, just for 1 minute. Once enabled, we can uninstall the package and app control logs the activity automatically. We can check the temporary allow activity logs to see the exact command executed and which user ran it. See this, it's uninstalled and fully logged, which can later be used for security monitoring. Also, we have the visibility of temporarily allowed duration. Let me show you the temporary logs. Hold on, where is the command? Alright, this is the one. We can check the temporary allow activity logs to see the exact command executed and which user ran it. All the start times, end times, and the total executables that ran will be listed here. Now, let's test with a non-root user. I'll use the test user that is having sudo privileges. Before switching to the test user, I'll copy the RPM file into test form directory and try installing it using sudo. In the same window, I'm opening the test user session. Let's see what this user can actually do. I'll use escalate the privilege and try to install it behalf of root to install RPM. Let's see what happens. Oops, let me quickly add the user as sudo. Just a minute. Let me edit the sudo file and allow the privilege escalation for the test user. Before running the sudo on app control, I will test the sudo command by checking the SSHD status. The SSHD status opens successfully using an escalated command which confirms that sudo is working for this user. Even though the user has full root level access, app control blocks the installation. The RPM wrapper will intercept the command. For anyone other than root, these commands will be denied for all users. This is because only the root user is allowed to violate or install RPM packages under app control. App control also generates dedicated logs for maintenance, mode, and temporary allow actions, which can be integrated with any SIEM platform for centralized monitoring and enhanced enterprise security. Even running app control commands with escalated privilege as a non-root user fails, ensuring strong protection. In summary, only the root user can modify app control policies or perform whitelisted operations. This ensures strict control over programs and RPM activities on the system. Thank you for watching.